Test, test, test. Test, test. Can you see? All right, I think you can see. All right, cool. Let's do some experiments then. Cool. So that's that, and that's that. And let me move this off to the side. Test. Oh, hey. Boris. Aldo. Hey, everybody. Cool. I'm trying an experiment right now. I don't know if this is working or not, but basically what I'm doing is I am trying a thing called Restream.io, and Restream will allow me to stream simultaneously to YouTube and to TikTok. And I've set up a half dozen cameras here, not really, two. So I've got something cool. So here's just me, one camera, right? And then here is my desktop, right here. And here is my desktop and me split screen. But I've got my breadboard right here. So what we can do is we can actually see what I'm working on at the same time. And I should be able to, if I did this right. What's that? I can do this. And I can go split screen as well. Right, I can go like this, picture in picture, or split. So I think my two main screens are going to be that one, and that one. Cool. Isn't that fun? Cool. So there's people on YouTube and there's people on TikTok right now. Isn't that fun? So friends, here's what we're doing. I've got a kit that I got from smartykit.io. We're using a Stream Deck, Boris. Thank you. And this is an Apple One construction kit. Basically, you buy this box, and inside the box, it comes with chips, computer chips and sockets. And it's kind of like IKEA for nerds, or Lego. And what's fun about it, exactly, Caleb, it's like Wozniak. Steve Wozniak in 1976 built an Apple One in his garage, and then Steve Jobs went off and sold the hell out of it. And this kit comes like this, and what we're going to do is we're just building this. Now, when last we left our hero, I was working on this here, and I got it this far. So let's just take a look here. We're going to do a poor man zoom in. I don't know if you can tell or not, but what we've got here is the screen. So yesterday we did the screen part of it, and we got this far. We're running off of 3 AAA batteries down here. Okay. And we've got a video controller and these 3 AA batteries right here. I'm going to actually turn that off. Turn it back on again. You can watch the screen start up. We don't have a computer yet. But what we do have is the beginnings of a computer. And if we take a look at this and then compare it, let's see if I can, I'm going to actually modify stuff a little bit. I'm going to change my screen here. Give me just a second. Just making a couple of changes here. Looks like this is a little bit tricky. What I want to do is I want to show you what we're doing side by side, and it looks like I might have a little trouble with that. So maybe that's not my cleverest plan. Plus, I'm going to need to flip that over. So let me start over. We have our display here, our I/O controllers. Then we have our I/O ports that don't exist yet. We'll have our CPU here, and then we'll have our memory down here. And you'll notice this light turns on here. So we've successfully distributed power from here, and we've distributed that power all the way down across 5 boards. And then we've also got power running along these rails horizontally. And you can see that we've given that power into this video controller right here. And in doing that, we have got ourselves in a pretty good position here, where we were able to power up our screen, and you see our little house powered up there. Now this is all done with a kit. The kit looks like this. And what's great about this kit, and again, this is not an advertisement, but I like these guys. They're a nice bunch of kids, is they've got a step-by-step JavaScript tutorial here. Look at this. I'm on step 44, and as you go through it, you hit these milestones, and if you look on the right as I push the button, you see how the wires are appearing as I go through the process. Isn't that cool? So I'm on step 44. You can see the next step, step 45 right here. Isn't that cool? AJ is asking on YouTube, is this a good way to learn how a computer works? It freaking is. You're building an Apple I computer from scratch. And you're building an Apple I from scratch, and you're learning all about it. This is a really great way to learn how a computer works. Another great way, there's a gentleman named Ben Eater, E-A-T-E-R. Ben Eater has another kit that looks like this, and I built a 6502 processor using Ben Eater's kit, which is pretty cool. So we're on step 44 of 200. Isn't that wonderful? Someone says, what are we doing? Well, we're going to build a thing. It's only 200 short steps. I've got a whole pile of stuff here. Let's switch back here. You've got all these wonderful bags, all perfectly laid out. It's going to set me up for success. Okay. So what I want to do here is I want to figure out a way to go side by side. And I need to make sure I can make this just a little bit bigger for you. So I am going to actually modify this. I'm actually making these changes in a tool called OBS. And I'm just going to make those changes briefly here. So do bear with me, because this is going to allow us to see the instructions on the right, on the left, side by side with what I'm doing on the right. There we go. Isn't that lovely? So here's my real hands, and here's my real computer. And what we're doing is we're following these steps, step by step by step. So you can see here, we're doing the Smarty Kit interactive assembly. We're on step 45. We've just succeeded in getting this guy to turn on, and we can see our screen. I'm going to turn it on and off again here. There we go. Thank you, Wayne. Wayne on the YouTube is helping me set up my OBS. I appreciate that. There you go. Look at that. So folks are saying maybe I've got this mirrored. Maybe I do have this mirrored. Aren't you all clever folks? Yeah, I think you are. So let me fix that. Thank you for letting me know that information. How's that? Is that better for you, friends? There we go. How's that? Is that better? Good deal. Okay, I think we're in a better situation now here. So, hello. How are you, friends? Thank you. There we go. So, we're building an Apple One machine from scratch, and we've got the instructions here. I don't know what's going to happen next because I'm just learning. And I've got this magnetic board right here. And what my magnetic board is doing is it's literally magnets because the parts are really small here. And I don't want these parts to fall. So I've got this wonderful magnet board from iFixit, and it's going to hold my parts there so they don't fall off. Isn't that cool? And the first thing that we're asking for now is it's saying that it wants a 10,000 ohm resistor. Okay, now the resistors, as we know, are color coded. And this one looks like it is brown, black, red. So I'm going to guess it's probably this guy here. But I don't trust these. I don't trust those things. So I always double check. I always double check these deals. So I'm going to take my helping hands here, and I'm going to take my resistor, and I'm just going to put it on the helping hands. And I'm going to triple check what our resistance is, because you can't be too careful. All right. There you go. That looks like it is in fact a 10,000 ohm resistor. You can see it says 9.6 because our scale is 20. So then I feel comfortable that that's probably the right resistor. That's the resistor that I want. All I need to do is have the kit plus a multimeter. This is called a multimeter here. And that's going to give me the confidence to do this and pull this off. Now, if we zoom in over here, we want our board here to look like this. And they just added this guy. So I'm just going to take that, and you notice the rows here. It's 30, 31, 32, 33. That's lining up with these rows over here. And you can see that the resistor, whoops, yay, oh no, what are you doing? What's happening? You can see that the resistor wants to go here and here. So we're going to have that resistor connected over here on the power, and it's going to move that power up. So now that power is running along this vertical rail here. So the power comes over here. Now you notice that this is kind of sticking up in the air. It's like, I don't know if that's a good idea. This guy here is kind of floating. I might chop that up. I might cut that later, make it smaller. And you notice that all my wires are kind of wacky right now. This great little kit here from SmartyKit actually pre-cuts a lot of these wires. It cuts them and bends them for you, which is lovely. But so when I get this working and I know what I'm doing, then I'll probably make that smaller. But I don't think it's important right now. Okay. Boris is also pointing out that you can go by the bands. You can, and you can triple check those, but I just like to know ahead of time. Makes me more comfortable. Look at the next step. Notice that jump there. We just jumped, and now we have a crystal controller. And we can see this controller right here. Now, do we have one of those? Let's go back to our little magnet board. We can see these guys. That says 16. Not sure if you can see that. Probably can't. Oop. That's a 16 megahertz crystal right there. And we're going to have that guy live over here. Can any of the parts be hurt by the magnetic iFixit pad? That is a fantastic question. In this case, no, because they aren't really kind of active parts. They're just kind of hanging out. However, it might be the case if I took some of these chips, if they had information on them, I might not want to put those on that magnet. It's a pretty weak magnet, but I'm going to keep these away. I'm going to keep those away. But that's a great question. Appreciate that. All right. Robert is asking how we're doing this. Let's just go back and confirm and talk about what we're doing here. So I'm using a tool called OBS, the Open Broadcasting Center. And what I'm doing is I'm streaming right now to restream.io. And then I'm sending this to my YouTube channel and to TikTok at the same exact time. So that's how we're doing this. So people are watching this both on YouTube and on TikTok. I've never done this before. I don't know if it's a good idea or not, but it's pretty cool. If you're just joining us, we are making a Apple computer, an Apple One computer with a construction kit from Smarty Kit, which is fun. And we're on step 44. We're going here and we're using this tool here. So we can see on the left-hand side where my mouse is spinning, we're on step 46. And then over here, we can see we just added this guy here. So you see, we want our left side to match our right side. And that's what we're doing right now, friends. I'll just zoom in a little bit more. Isn't that great? Thank you, Angel or Angel. Appreciate that. Now Gabe is jumping ahead and asking, where's the adder? Where's the adder? Well, we got all of our chips over here. We're going to add these as we get to them. Okay. Now there's two ways to build something like this. You can build it from actual first principles, or what are called 7400 series parts, but we're going to be doing a little bit of cheating because we have a CPU here that's going to get us started. We're actually building not a CPU, but an entire computer. Okay. All right. So let's go and look what's next here. We have the keyboard controller. We're going to be hooking up a keyboard right now. Now remember, we can turn this on right now. You can see our screen turn on. And we have a hard-coded little screen, but we don't have a CPU yet. We're not really outputting anything of use. There's just some text there. ThinkBucket is asking, what am I going to run on this when I'm done? That is the real question. What I'm going to run on it is Apple Basic. And I'll run some Apple Basic applications, which will be fun. This is a great way to learn about computers. All right, so here's our keyboard controller crystal, and we're going to go to the next step. And you can see there's a moment there where the crystal capacitor, we need a 22 picofarad crystal capacitor. So I'm going to go back over to my pile of stuff here. And I think that these guys here are 22. So I'm going to pull one of those off. I want to point out that these are really long. Some of these are long, and I probably need to cut them. And I need to figure out when I'm going to go back over my board and tidy up, because right now it's a little messy. A little messy. Yeah. Caleb says we should run Oregon Trail. That's a genius idea. We should run Oregon Trail. I grew up on Oregon Trail. So we're going to take this guy here, this little capacitor, and we're going to put him right there. Happy little capacitors. And then we're just going to confirm that that's where that needs to be. And we can do that, again, by comparing on the left side with the right side. And you can see that that pretty much looks like that's where that needs to be. It's hanging off of the negative and the black there. So we're going to follow right through that. Connie, over here on TikTok, Connie Codes, she's got a great TikTok channel. I encourage you to check that out. She's talking about being a software engineer. She's been a software engineer for a while, has joined me on the live yesterday, and is saying that she needs to pick up one of these kits. You do. Get on board, Connie. We're doing all kinds of fun stuff. I like this kit because it doesn't require any soldering. It's fun sometimes just to use a breadboard and learn about these things. So we got two little capacitors here. Now you notice something interesting. We've just added this capacitor. Now we're starting to make some connections here, because this capacitor is on the negative, and now your power is going to go like that. So it's kind of, that didn't really turn out very nice, did it? Let's try that again. Because you can see that we go up and around and back down. So we're going through that crystal. We're going through that crystal. Manuel says we can build a split mechanical keyboard. If you follow me on TikTok, you'll see I actually built myself a keyboard. My wonderful friend Tala, T-A-L-A, on TikTok sent me a keyboard kit, and I built this from scratch and soldered it. And this is actually a 3D printed case, so now I have a 3D macro pad that Tala gave me, which is fun. Now, Connie says soldering is fun. She's right. There is fun with soldering. But I didn't want to solder this from scratch. I do have some soldering videos earlier, and I just made a lightsaber, which was fun. So if you're just joining us, just a reminder, we're building an Apple I computer from smartykit.io. It's a fun little thing here. Boris on YouTube says that he loves soldering. That's great. I need to get better at soldering. All right, so let's move on to the next step, step 49. Whoa, look at this. What are those? What's this going on here? Okay, this is cool. So what we got here is a fun thing that now shows us how this particular kit shines. Because what they do here is they give you these little holders for the chips. And I think this is a really clever idea, because what they're doing is they're making it a little bit easier for you. Here's why. That's not a chip. Okay, that's just a thing that will hold or socket that, but it's pre-labeled. It's pre-labeled, and it's got all the little names and locations on it, which is great. Aldo is suggesting for me to record a clip so that anytime someone shows up and says, "What are we doing?" I push a button. GDM on TikTok says that's a huge board. It's actually not a huge board. It's actually 5 little boards. 5 little boards all connected to each other. So I just pasted them together. Just pasted them together. Okay, so what I was saying was that this is going to hold the keyboard controller. Now the actual keyboard controller is over here. Okay, there's your keyboard. So this guy here is our chip. Now, why do I need this thing? Come on, there you go. Focus. Come on, I'll focus. Because I could put the chip in like this. Could just stick it there. And that would be fine. But the problem there would be I could bend these guys. I don't actually know the numbers of each of these legs. But with this, it's actually split those out. It's made them easier to read, and they're labeled. And that's going to make my life a lot easier. So what we're going to do is make sure that this lines up correctly. So I want to point out that we have OCS 1 and OCS 2 connecting to our crystal here. So you really can't see that too much right there, but it says OCS 1 and 2. And I'm just going to make sure that those line up, because I don't want to make a mistake. And I'm going to move that crystal just a smidge out of the way, push that in there, and then bring him back over. Now they kind of bumping up against each other. So I'm just going to triple check underneath that that's working okay. You can see over here, they're kind of butting up against each other. And it looks like in reality, they're really butting up against each other. Okay, but I think that's in there enough. And that works nicely. So then I'm going to take my keyboard chip there. I'm going to put that up there. Eric on YouTube is saying that I have a future in ASMR. I never understood that. I don't know what that is. Too Old for Tea on TikTok is saying, what are the vertical chips for? These vertical chips would allow me to connect a ribbon cable and then listen in on what's happening. So if I got a little tiny oscilloscope or something, I can get more information about what's happening on this board. So it's going to give me access to that in a very convenient way. Isn't that cool? So if you're just joining us, we are making an Apple I computer from scratch. Right now we've got it to put a screen on. But so I'll show you our screen. Let me plug this guy. I want to make sure I get this guy in here. So we're doing the keyboard. We're hooking up the keyboard. This is going to let me connect to stuff. Let's turn this on, make sure it still works. We may have, yeah, debug with a ribbon connector. That's exactly right, Jason. Jason Bourne on YouTube. There's our boot up screen right there. Too Old for Tea is asking if I have an oscilloscope. I loaned it to my nephew. I have a little one called a Pocket, P-O-K-I-T. It's a really nice little oscilloscope that you can get very cheap, and you can attach it to your iPhone, which is great. So you actually connect it directly to your iPhone, which is pretty fun. Again, just a reminder what we're doing today. As I see, we're getting a number of people on the show here. We're making an Apple computer from a kit to understand how computers work, which is great. I've been seeing these guys on TikTok lately doing a bunch of nonsense where they're tapping on a calculator to make it go up to 100, make it go up to 1,000,000 or something. And I thought that was garbage. So I thought it'd be more fun to talk about something interesting that actually has value. So we're doing this instead. So now we just added a short red wire right there. And what's great about this kit is they've pre-labeled everything just like IKEA. So we have SR, which is short red. And this little kit from Smarty Kit is actually doing that. So look at this. Pre-done. Got to hold it up and get focused like the makeup people. And we're going to put that from VCC. This right here is VCC. That's your voltage. And we want to notice that that's going all the way down here. So your voltage is going from here down. And we're going to hook that guy up. And we're going to send it down to our red, our voltage line. Now this is where we get into that issue again about the length of these wires. Some of these wires are maybe too long. I will probably go through one by one and cut them when I get it right. But I want to prove that I got it right first. So you got to see it work, then you cut, right? Because if you cut it right off the bat and then I make a mistake, I'm going to be in trouble, which will be a problem. Isn't that great? All right, so let's go back and look at our documentation. We're on step 50. 51, it looks like we're adding a short black connector right there. And you can see right there it says ground. That makes sense. So we're using red for voltage and we're using black for ground. Short black connector right there. Yes, Man from LA on YouTube. It can, in fact, be programmed in BASIC. That's exactly what we're going to do. What we're doing here is we're building an Apple I computer from scratch, and we're going to run Apple BASIC on it. But we don't have a keyboard yet, so we need to turn on the keyboard. We need to make this keyboard actually work. So you can see over here that I'm going to hook up the keyboard controller right here. And when we do that, that keyboard controller will hopefully then let us talk to a keyboard. But then I suspect I'm going to be running all over the house looking for an actual keyboard, which will be a moment, because I think it's going to want me to find an old keyboard. Now, this is a great point. Mike Wagner on TikTok makes a really great point. He says, imagine Steve Wozniak, doing this in 1976 in his garage. Isn't that crazy? Samuel just joined. Hey, how are you, Samuel? Good to see you. All right, so we just added our ground. Let's go to the next step. I'm looking at this here. Notice that I click backwards and forwards, and I see that little red line up here. I want to see that red line up here so I know what I'm hooking it up to. Looks like we are here on row 39, and we're going to do a short red connector. And then what we can do with our multimeter is we can check these wires at any point, confirm that we're doing what we're doing. This is a great way to learn how computers. Clark on YouTube, I'm going to give you a hard time, Clark, is sad that the documentation is not HTTPS. I think that building a computer from 1976, the least of my problems are whether or not the documentation is secure or not. But let's see if we can make it secure, if that bothers you. Nope. So you're going to have to deal with insecure instructions. So we are on keyboard controller. And now we have our clock resistor right here. This is going to be a 220 resistor. Now we talked about how resistors have color. So you can look at these resistors and then pick the ones that we have. And that looks like a red, red, brown. Now I am a real paranoid about resistors. I don't want to make a mistake, and I like things to work on the first try. So I'm always testing mine first. So I'm going to go and hook that up to my multimeter first, and I'm just going to check it because I don't trust anything. Trust but verify, I think the kids say. So we're going to just double check that that's in fact what we think it is. That is in fact a 220. So now we know that I can rely on that resistor to do what it says it's going to do. And it looks like it's at 55 up here, and we're going to be connecting the ground. You can see the rows here. You see how we've got a row, we've got A, B, C, just like playing Battleship. We can actually see where those are going to connect. So we're going from the negative rail, 54. And we're just going to hop up and give some connection up here. Now we don't have anything hooked up yet, but we're getting there. So we got 54 set up there. Let's see what step this is. Again, if you're just joining us, friends, we're making a, oops, there we go, making an Apple I computer from scratch. Yeah, Too Old for Tea has a great question. Color codes on a resistor. Color codes on a resistor. They do actually have meaning. That's a great question. They're asking, do those mean something? They actually do mean something. There's a color table for resistors. So each of those resistors has different colors on them. So like here's, I'm holding these up. We've got orange and red and black. Those are actually digits. Brown is 1, red is 2, orange is 3. So yeah, they're not random. Isn't that cool? They're not random. They are in fact set up, and they have a multiplier. So a yellow can mean a 10,000 multiplier, or it can mean a 4, depending on what you're doing. Great question. Great question. Good stuff. All right, so we just put that one on there. We're step 54. Now, the low rate clock LED wire. We're going to actually have a wire. I bet you this is going to be cool. I'm guessing what they're going to do is they're going to give us an LED that's going to blink, and it's going to blink like this and tell you when the clock is running on the device, which is going to be cool here. So we're going to go and show that again. So we're going to switch back here, and we're going to do a pre-done yellow wire. KR, thank you so much. I appreciate you over on TikTok for saying hi. Now, is this going to be long enough? I feel like it will be. We're going to go from the 55, the row 55 here, and we're going to go all the way up. Are we long enough? Scandalous. I may go down just one, and we'll plug in right there, just barely. Now, you see how nice that is? That's what I want all these wires to look like. You can see some of these are kind of wacky. In a perfect world, I would cut each one of these individually, but then that would be a whole thing, and then this wouldn't be a computer building show, it would be a wire stripping show. And all I would be doing is wire stripping wires. Now, Jason on YouTube makes a great comment. He says that look at these board 1, 2, 3, 4, 5, reminds him of a software stack. That is actually a really great observation. This is in fact a stack, isn't it? Memory, CPU, I/O controllers, and ultimately the TV. So great observation. We in fact do have a stack right here. Let's see if we can get our focus back. Come on, little webcam, you can do it. All right, let's look at this. Next step. Oop, look at that. It's time for the LED. I knew it. I felt there was an LED coming, and this is a good reminder to us. If we go back over here and we note that LEDs have direction. LEDs have direction. So you see here the anode, or the positive, is the longer lead. It has a longer leg. And the cathode is the short. So most people will bend them like this. So this is your positive. So that's important. Otherwise you'll burn out your LED. So let's go back over here and see what we're trying to do. Looks like that's going to sit there. And you see how it bent out that leg in the picture? It bent that leg out because that's how it's supposed to be done. And this is another reminder. It's a little hard because you have to kind of visualize it. But where's the power here, friends? Where is the power? How is the power moving its way around these boards? As a reminder, we have a bunch of batteries in here. It's just literally a bunch of AA batteries. Okay, let me close that up. Come on, batteries. Why are you going to do me like that? I'm telling myself I'll just open the batteries up and they'll close up. Well, you're open now forever, I guess. So we have these batteries, and we're sending the power here, and then we're sending them down and down and down and down and down, right? The power is running horizontally on these red lines, and then vertically once you get here. So you can see that we're actually grabbing our power here. We're going to have to grab, they're actually, this is interesting. Let me zoom in on this a little bit better. We're stealing the power off of this guy. That's our clock right there, A5. And so there's power on that pin, and it's going to go up, 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 through the LED, and then back down. Does that make sense? All right. I'm seeing about 500 people on TikTok. We're building an Apple One computer from scratch because why not? Because it's awesome. Because we should. Because it sounds fun. Because what else would you do? Watch Netflix? Come on. Focus, people. Focus. Step 56. Ooh, we got our first big wire here. First big wire. Looks like it's L for long. Let's go looking for that. I've got all these bags. Short black and short. Looking for our long wire. I'm just running through all of my stuff here. Oh, there it is. Oh, look at these. I didn't know I had these. So we've got some giant ones here. These might want to be made smaller. I'm feeling like that might be a little bit overkill. That seems a little out of control. So we'll see that one here. User 401495 is asking, will this content be on my YouTube? In fact, it's on my YouTube right now. We're using Restream.io to stream this to 2 places at once. Yeah, you see how long that is? I'm actually going to try something here. I haven't cut a wire yet. We're going to go from 47 over to 21. So I feel like that could be shorter. So I'm going to cut that. So I've cut this wire here. And now I'm going to take my wire stripper and set the size of that wire. Look at that. Look at that. Beautiful. Isn't that nice? I'm going to have to do that at some point and tidy up the whole thing. Michael says, what is the price of the kit? This is not an advertisement, of course. I'm just a fan. I'm not familiar, not affiliated, rather, with the company. But this is called smartykit.io. I think it was $2.99. And we got it at smartykit.io. All right. We got D5. It's kind of IKEA for nerds. D5 to D3. Look at that. That looks like the picture. Probably could make that smaller. I could make it flat. There's all kinds of ways I could figure this out. So I'm going from D3 over to D6 to D3. That is going to be our print character input. So from our print character input on D3 to our key ready. That's going to actually be our keyboard controller, friends. Isn't that great? Okay, step 57. We're going to have a terminal when we're done here. Okay, next character is going to go from D5. Now look at that. Look at their JavaScript there. I'm going to make sure I get that right. So I want to make sure, because we have 2 blue wires here, I don't want to screw this up. So I'm going to go and look at it like this. Now, I did cut that. I wonder if my other wire is long enough and I could cheat and use that so I don't have to waste a wire. Okay, so check this out. So we went from D5 to D3. So this is D3, 4, 5. barely long enough. 1, 2. Oh no, are we gonna make it? Scandalous. I might want to go underneath. See if we can do it, because I don't want to waste a wire. This is a bit sus, but still should work. And this is where it's super important that you get your wires right. To D5. Yeah, barely long enough. Oops, don't bend it. Don't bend it. There we go. Look at that. Hee hee. Okay, let's confirm. D5 to D3. Now, you see how nice and small that is? Like, that would be like perfect. I should do the same with this, but I don't know what's coming next. So I did pull that off without wasting a wire. That's pretty cool. Problem will be, of course, I bet you we're going to learn later that I need to get in here and I'm going to be blocking a bunch of stuff. So we'll see. Something to watch. D3. Kirill, thank you for your help on YouTube here. Oh, wow. Looks like we're doing a lot of these. We're setting up a keyboard data bus. Now, a bus is a whole series of wires that are going to send information from chip to from pin to pin. So we're sending from the keyboard to the video all of this information, which makes me think that these long wires are going to come in useful, and we're going to do a couple of them, which I think is interesting. Hello, just making sure that you know there's a human here. I'm a real guy. All right. So what I'm going to do is I'm going to try to be more smart about my wire situation here, because I'm suspecting we're going to be doing this again. So what we're going to do is just cut one of these guys in half. And we're going to just strip those wires. There we go. So what are we doing now? 6 to 6, D6 to D6. 4, 5, 6. 2, 6 over here. Look at that. All right, cool. Go to the next one. This is going to get crazy. That looks like 7 to 7. Yep. 7 to 7. Let's see if my strategy is going to pay off. 7 to 7. Look at that. Lovely. Okay, cool. Working so far. I can refactor after, says Roberto. Absolutely right. Very wise words. Now notice here what we're doing. This is really interesting. We're starting to see a bus, right? And a bus is just a bunch of wires, bunch of traces that are all in a row. 1, 2, 3, 4. It could be a 4-bit bus sending 4 bits. Could be an 8-bit bus, but there's some number of them. And we're creating a little bus to carry information from our video, from our keyboard over to our video, which is great. Oop, Michael says to stop. He thinks that I've done the D5 wrong. D3, D4, D5. 6, 7, 8. 6, 7, 8. No. I'm feeling decent about that. 45, a space, then another one, and then 3 more. So double check that for me, Michael, and we'll see if I'm right. Thanks for looking out. Yeah, Clark is asking about the Ben Eater kit. For those of us who haven't been here before, we're building a computer from scratch. This was a kit from Ben Eater. It's a 6502 assembly kit where you can build your own processor. Here we are building an Apple One kit from smartykit.io. Got some of our chips here, and we're currently on the keyboard. So right now we are on keyboard. Go to the next one. Looks like another one. Cool. Good thing that I made these wires here already. Again, the kit came with some pre-done wires, but I went and cut one in half because I had a sense that this was going to happen. Now this will be D9 to D9. There we go. See how we have nice 4 wires. Oops, you can't see. Sorry. Nice 4 wires going from here to here. So we're going to confirm that. 5, 6, we got 2 more. 10 to 10. So we'll go back over here. We'll grab our kit, grab our pre-done wire here. I'm going to cut this in half. The way I'm going to cut it in half is I'm going to fold it. Take my Swiss Army knife. And then I'm going to just strip that wire. These are wire strippers. These are wonderful. They have numbers on the side here, so I can just tell it how thick the wire is, and it just makes your life so much easier if you're doing this kind of work. All right. So we're going from D10 to D10. It's getting a little crowded in here. A little crowded. But I think we can do it. Okay, and then I'm going to guess, controversial opinion, yep, they're doing another one. This is where it really starts to make sense. Like you literally have voltage on a wire. So we're creating a bus to connect these pins to these pins. Now, this is super interesting because if you have a board of some kind, and that board has a trace underneath it, a trace is all of those different wires. Let me grab an example. I'll just grab a Raspberry Pi. Here's a Raspberry Pi. You see all these little lines? That's literally a wire. So there's no difference between this and me moving wires from pin to pin and them having wires go from pin to pin. Isn't that cool? See this here? See that? That little road? Let's zoom in on that. That's a bus. That's a bus. So we're making a bus, it's just that our bus is wires. Isn't that great? All right, we're going from D11. I think we did. Did we do D11? No, we did not. D11 to D11. And then D12. There we go. All right. Oh, did I need to cut another wire? I did. Did I lose my wire? Nope. Let's go back and do that. So we're going to take our wire, we're going to cut it in half with our wonderful Swiss Army knife. And then we're going to strip the wire, removing the plastic on the outside, exposing the wire on the inside. There you go. Get these guys out of here. Get out of here. And then we'll go back down here. And we're going from D12 to D12 on the left to the right. So we got D12 to D12. Are we going to use D13? Let us find out. In fact, we are. So we're going to complete our bus. Going to complete our bus here. D13. Now we're running out of room. So I'm going to have to think about what I want that to look like later. But for now, that looks pretty darn cool. pretty darn cool. All right. Ooh, what's this? Oh, something fun happened. Something fun happened. New connector just showed up. New connector just showed up. Cool. All right. So this is good. What's going on? Well, we're going to need to plug in a keyboard. And I don't know if I have this kind of keyboard. So we're going to have to figure this out. A PS2 connector. This is an old style keyboard connector. You see that? That's how keyboards used to work before USB. Question is, do we have one of those lying around? I will look for that in a little bit, but right now we're going to look at this text here. We can see voltage, or what's called VCC, and ground, GND, and then we have data and we have clock. All right. So what we're going to do is we're going to position this the same way it is in the picture. Okay, so we have data and clock over here, and we have ground and VCC down here. And then I bet you we're going to give power to this thing. So it looks like they put data on 60, and they put VCC on 60 as well. Look at that. Isn't that beautiful? Okay, cool. So look what's going to happen. I'm going to turn this on its side. That's where our keyboard's going to go. That's where our keyboard's going to go. So we're actually going to be able to have a keyboard here plugged into this little computer, and then if we did this right, we're going to be able to type on it, and we're going to see that output on the screen. Now, we don't have a computer yet at that point. We just have a thing that echoes. We're going to be echoing keystrokes back to ourselves, but that's pretty cool. We just got to figure out how to hook that up. All right, step 67, PS2 power connector. I'm just going to move this over just a smidge so you can see more. There we go. PS2 power connector. You see how great this tool is here. Basically, each time you push the button, they draw on the screen there. So there you have your voltage. Remember, we said that was going to happen, didn't we? We said that was going to happen. Now, Caleb in the chat here says they have a PS2 to USB adapter somewhere. Roberto makes an excellent point here. This is a great point. So Roberto points out that PS2 is new for an Apple from that time. That is absolutely right. It, in fact, did not exist at this time. So this kit here that we're building, this kit is from this company. I think it's a small business called Smarty Kits, Apple One computer kit. They had to find a balance. This is my guess. They had to find a balance between modern stuff and non-modern stuff. I just went over to Goodwill looking for a PS2 keyboard, so I'm pretty sure I'll be able to have one around here somewhere. But your point is well taken. They, in fact, USB didn't exist in 1976, and I don't think PS2 did yet. PS2 didn't happen until, I think, the early 90s. But great points. I'm also noticing something interesting here because I may have made a mistake earlier. Not a mistake, but like didn't think it out. You see how I don't have enough room here? I'm going to move these guys to the left. So we're just going to pick that guy up and move him over. This was our power. That's okay to do that. So now we need to make sure that we have voltage to our PS2 connector right here. So VCC to voltage right there. And I'll bet you $1.85 that the next thing is going to be a short black wire. And I bet you they're going to want me to connect right there. So let's find out, shall we? Bingo. Nailed it. We're learning about computers. We're building our own computer. So we've learned something now. We've got our short black wire now. And this is great because the kit includes, just like IKEA or just like Lego, we're learning how to build a computer from scratch today. I hope that people are enjoying themselves and maybe they're making dinner or they're hanging out, but doing something fun like this is a way to burn off steam. If you have a job that you're challenged with or you're tired, go and make something. So there's our ground. So now we're giving power and the ground. That ground wire doesn't want to go in there. Try pushing a little harder. Why is that not going in? That doesn't want to go in there. There it goes. All right, and I'm just going to bend it and make sure it goes in here. Notice that these are popping out a little bit. I want to be conscious and aware about these. I don't want to mess anything up because I need to make sure all these wires stay where they started. Otherwise, this thing's not going to work. And debugging it is going to mean running through and looking for all these different wires. When I'm done, I think I'm going to mount this on a wall, and then I'll have a working Apple computer. All right. Now my guess is now that if you remember, we have a keyboard module here. Let's zoom in on that. Here's our keyboard module. We need to get stuff into here. How do we get stuff from the keyboard into here somewhere? So I'm guessing we're going to have some wires going from there to there. So let's see what's next. Yep. There we go. So the data on the PS2 connector right here is going to go to D2 on the keyboard module. Rob is asking if I'm going to make a PCB or if I'm going to keep this like this. You can get a PCB, I believe, from the folks over at SmartyKit. I'm doing this for fun because I want to learn how these things work. And I will probably just mount it on the wall like this. I'll make a board and I'll have the little screen at the top and a bracket. Maybe I'll 3D print a case or something. There is a prettier board that you can get from them. I'm going to D2 here. But I'm not too worried about the aesthetic yet. I'm worried about the functional. Now this is going to mean I'm going to have to get up a second here and look down because I can't see D2. So we're connecting the data line of our PS2 connector to our keyboard controller. Okay, that looks good. I'm just making sure that that's the way I want it to be. And then let's see what the next step is. Oop. They popped up a thing that says that it'll work now as soon as I finish this. So it looks like the clock goes to D4. So let me do that, and then we're going to go and find a keyboard. For folks that just joined, we're getting to an exciting moment here. We're building an Apple computer from scratch from this kit called SmartyKit. And what we're doing here is connecting the keyboard controller to the video controller to make a terminal. We're streaming live on both TikTok and on YouTube here. And Sevens is saying, is it weird the keyboard to TFT has individual bit lines, but the PS2 connector is bytes? I think that is probably a little bit weird, but that's just chip design, right? Like this thing is thinking about stuff differently. So that the process of getting data from the video controller to here is the language that this thing speaks. The process of getting, information from the PS2 connector to here is the language that speaks. Translating those kind of things is a part of life. Boba Fett on TikTok wants to buy the kit. You can get it at smartykit.io. I'm not a member of their company. I'm just a guy. They seem nice. So I'm not affiliated with them. There's no like referral codes or anything. But tell them I said hi. Smartykit.io. All right. So now, according to this, we should have a working terminal. Test keyboards with LEDs, or connect a PS2 keyboard auto start, just like a real terminal. Okay, I don't know if that's going to work or not. So do I have a, I'm looking for this keyboard now, so I have to look for a PS2 keyboard in my room here. So let's do that. So let's find a keyboard. Do I have? think I might in the arcade here. Hang on. I think that the back of my arcade is a PS2 keyboard. Right. PS2 keyboard. So, theoretically, I don't know if this will work or not. Theoretically, I should be able to plug this in. I don't know if there's a driver needed or what. Ooh, it's a little dusty. We have a keyboard now. And we have a terminal. So the question is, though, test keyboard with LEDs. Well, I don't know. How's that going to work? All right. Well, I guess I just turn it on and pray. I always think things are going to start smoking or blow up at this point. That's flashing. That's the clock. That's a good sign. And that's outputting something. That shows me that the video works. So I don't see anything happening with the keyboard. And none of the, do the lights turn on? None of the lights are turning on. So I'm going to double check my voltage. So the data and the clock are on D2 and D4. And the instructions, test keyboard, oh, after the test, the 10 wires should be removed. They are temporary for just this test. Did the keyboard LEDs, Jafir says, did the keyboard LEDs blank when we turned it on? Great question. Let's find out. They did. Okay, that's good. That's good information. Thank you for that. These did turn on. So that says something. And this light is blinking, which lets me believe that it is showing the clock. But I'm not getting... Just making sure I haven't missed any wires or anything. And I'm going to back up a second. Maybe a connection to the PS2 adapter is not passing power. That's a good question. That's a good point. Let's see. So if I unplug that, turn it back on, our screen still turns on, which is a good sign. Now we can take our multimeter right here, and we can measure if we have voltage on these two pins. All right. So we are getting voltage right there. So we are getting power to that guy. So that's a good sign. That's a good sign. Rob Barber, who's asking a question on TikTok, is this a 6502 or a 6510? This is in fact a Motorola MOS 6502. We're building an Apple One from scratch using this kit from SmartyKit. And what we're currently doing right now is we're testing the keyboard controller. So I'm just like looking around, making sure I didn't do anything obviously wrong. Just making sure I didn't do anything obviously wrong. And we have our PS2 keyboard here that we got. And we're going to plug that in. Now, one thing is concerning, though, is it says upload Layboard driver with auto start and type. So I need to figure out what that means, because maybe that's a step that I'm missing. Because right now, this guy starts up, and the keyboard, you can see the clock going, and this is just the default screen. Jason's asking where the keyboard driver is. This is the instructions, so the instructions are figuring this out. Now I notice, though, when I turn it on, it starts flashing. So let's go figure out what this is. Maybe we can watch this YouTube video here. Oh, well, that's interesting. Okay, so look at this. This guy has plugged in LEDs and is basically lighting each LED up by looking at this data line here. So basically, every time you click on something, he's pushing the numbers, see? And that's showing you the bits on the wire. So that's a thing. I don't have any LED. I don't have that many LEDs, though. So let's find out what a Layboard driver is. Maybe that's a misspelling. Did he just type Layboard and he meant keyboard? That's not awesome. Jason points out that those are near each other. Upload the keyboard driver. I don't like that, kids. I don't like that one bit. So here's all those wires. Yeah, see, this is like already finished, and I am not there yet. So that's not good. So I got here, test all. Okay, after the test, all 10 wires should be removed. I think what I want to do is just, I think I'm frustrated that this keyboard driver is mentioned at the last possible second, but they're not telling us anywhere what that means. So let's switch back here and let's just confirm that these are correct, because I don't know where to get that. Otherwise, I'm just going to march forward blindly, which is fine, but I would like to have seen that work. Someone just said hello from Tokyo. Hello. Does the keyboard controller require programming, or is it ready to go? Actually, that's a good question. There's no way for me to program it because I don't actually have a chip programmer here. That's good. Someone on TikTok says they're the drowsy something, and they said, say hello, hello, this is live. I'm looking at the way that I plugged in the keyboard controller, and I'm confirming that all those chips look good. I'm actually wondering what's happening on these pins here, and if there's something I can look at, because I'd like to see that. And being able to see what's happening on the keyboard would be great. So where would the keyboard driver go? I presume it comes on this. So let me confirm that I used the right chip. We pulled out the keyboard chip here. And we put it right there. If we turn it on, our clock is on, which is cool. Our data is going from here to D2. And our clock, I'm going to pull the clock and see what happens. I'm expecting that the light will no longer flash. But if I add it, I would have expected that it flash. The other option is that my keyboard's bad, and I could get a USB adapter right here. Oh, there's a Discord. Pull the clock LED and put it on a bus line. That's a great point. So we've got Sevens on the chat here on TikTok who's suggesting that we pull out the LED. I have an extra LED, and I know I'm supposed to have a resistor to do this. Now you notice how the clock is flashing right now, but I feel like as soon as I push a number, well, I'm pushing buttons on the keyboard and nothing's happening. So that's a good sign, I guess. I thought before, when I pushed a number, it stopped flashing. Pull the clock LED. So which bus line should I put it on? So this is where we get into the positives and negatives of it all. The positive is running off of... Does the keyboard work? Yeah, it does. I mean, it worked. It worked 10 years ago, and I put it in my arcade. And I want to point out that we had the observation that these lights here, if we turn them on, see, they just lit up. They're actually flashing. That's interesting. Hang on. That's new. Is that bad? Actually, hang on a second. If those are flashing, do I have the clock and the voltage reversed? That could be interesting. We're on step 70. Let's back up a smidge. Data is here to D2. And clock is D4 to clock. Johan says in rocket ships a flashing light is not a good sign. That is a good tip, man. That is a good tip. Hi, Shaquille on TikTok. How are you? We've got D4. That is correct. Plugged into the clock. Okay, I just checked all those settings, and it's no longer flashing. So that's a good sign. I'm going to look carefully. I may be wrong about something here. I'm going to let the power drain out a little bit. Turn it back on. I might have a short somewhere. Does it matter what vertical hole you use? David Sethel is asking on YouTube. It doesn't matter. That's a great question. Because down here, the verticals are leading up. So the entire vertical is connected to that. So it does not matter. That's a great question, though. Great question. Now, I'm noticing that sometimes the screen turns on and sometimes it doesn't. Check the keyboard device light behavior when connected to a known good device. Smart. I'll have to turn my arcade on to do that. Good advice. Good advice. So I just want to look down here. Okay, that says AD1. If I push buttons on the keyboard, nothing's happening. Can I see data on this line? So there's a negative 5 volts. There's negative 5 volts on. Oops, I got it reversed. there's 5 volts on the data line. This is where I need an oscilloscope, because I want to see that go up and down. And I feel like that's wrong. This is where I don't have the tools that I need. See, it's moving up and down. I think I'm at the end of my ability here. This is frustrating. 7 says I could call for help. I'm calling for help with you guys. This is you're here to help me. I think that the instructions. Can you move up one of the PS2 connectors close to D2 on the keyboard module? Can you expand on that, Jason? Yeah, so people are saying the bus might not be working. So let's confirm each of those. Oh, that could be true because these don't look all pushed in all the way. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 wires here. 2, 3, 4, 5, 6, 7, 8. Rob Barber is offering me an oscilloscope. Jason, tell me more about what you said. You said move up one of the PS2 connectors on D2, close to the D2. So I've got that data connector directly onto D2. What I need is a bunch of LEDs, because I need to see what's happening on each of these data points. And I'm thinking out loud about what I can do to temporarily get some light. Yeah, I don't think I'm getting anything. Let's try D2. Okay, I need a resistor to be responsible. The clock connector. See, I need someone to join me now. So, for folks that are just joining us, you're watching me suffer as we are making an Apple computer from scratch, Apple One computer from scratch. And what we're currently doing is we are turning on our Apple computer kit. We're on step 70, and we can see if we did it right. We're trying to see text output here, but I am concerned that maybe this guy did not get hooked up correctly. Now, Jason on YouTube, yes, you notice how it's not turning on every time? Jason on YouTube is making an observation that the clock connector. Oh, okay, let's see here. So Mino is saying D2 to data. Yeah, D2 to data. So there's D2. There's D4. D4 is on the clock. Reseat the chip. That's also a valid suggestion. I'm looking at the chip and I feel like it's pretty good. So Jason and Minu, are you saying it's wrong, or did I reverse them? D2 is on the wrong line. Okay, let's pull them out and start over. So we have our data, which is here. Agreed? Okay. That's okay. We'll figure it out. So we've got our data. That is the right line. That is D on the diagram. Let me zoom in and make the observation, because what we're going to do is we're going to confirm this guy right here. So we're talking about the data line. Usama says it's a very expensive hobby. It's actually less than you would think. Right now I have a $10 oscilloscope and a bunch of friends on TikTok. So data to D2. Okay, do we agree that that's correct? Move D2 down a bit. Okay. And then we've got the clock on D4. All right. Do we agree on that? You can. If you're on YouTube right now and you're watching this, you can check it out. It's also happening live on TikTok. D2 should be on the same line as the blue wires. I am respectfully not seeing that. Do you think it's a mistake in the instructions? Folks are saying they think it's going to work, but nothing has changed. Gotcha. So clock to D4, data to D2. In the instructions, it's on the same line as the blue wires. Okay, let's talk about that. So I'm seeing D2 here. Oops. D2, D3, D4. Okay. Yeah, this is a great point. This is a great point. Ben Pope points something out here. He's pointing out that these are called breadboards. And breadboards are really kind of funny things because the way that data flows through a breadboard is horizontal and vertical in different lines. So this part of the breadboard here is horizontal. This part is vertical. So the vertical placement of these is not the point. The data, if anything goes in a line here, that's all the same. Okay, so I can put these wires up anywhere I want. So if we look at it in the context of this right here, that's a row, or column rather, pardon me. So D2 runs along this here. I can put that anywhere I want to, vertical or otherwise. So Mike was saying, well, maybe D2 could go down a bit. Shouldn't matter. Shouldn't matter. And an observation was, does the timing matter? Timing doesn't matter on a PS2 device because our clock is at 1 megahertz. So it's only hollering 1,000 times a second, which is not a lot. Great question. Kirill is pointing out, are the capacitors well seated? That's a very good point. Let me make sure that those are all correct. Thank you for that. So let's make sure that those are correct. We're just going to double check everything. So capacitors are seated correctly. I don't see any missing wires. The bus, I'm 99% sure is correct. Yeah, that was touching the LED, but it shouldn't matter. Okay, try it again. Oh, Kirill says he sees a metallic dash that's not in the scheme. Aladdin is making an observation. Does it need to match? It needs to match logically, but it doesn't need to match physically. So, for example, we'll make an example. You See this yellow wire right here? That can be anywhere in any of these 5 vertical dots. It doesn't need to be exactly. Toby is asking if there is a missing wire from D3 or D4. Let's find out. So I see D3 and I see D5 right there. Okay. So is there a missing wire? D3, D5, D3, D5. And let's go and confirm those. We can see D5 to 3 and D5 to 3 right there. All right. Ah, this is funny. I love this question here. I'm going to come up here. So Web Developer Ninja says, I thought he worked for Microsoft. Well, so that's a great little troll there. I love that because, my friends, we're building a computer from 1976. If we were doing web development, I'm your guy. But I was 2 in 1976. And I haven't done electronics like this in about 25, 30 years. So, yes, I do work for Microsoft, but debugging breadboards on 6502 machines is not a Microsoft interview question. So, in fact, a good point, but not a skill that that matters right now. But that's cool though. I appreciate that. That's funny. Yeah, it turns out that it doesn't matter. All right. Or at least it doesn't matter to, you don't get a job at Microsoft because you know how to do this. Yeah, I'm learning. Learning just like you are, my friends. So that makes me wonder if I should ask a vice president at Microsoft if they can do something like this. What I need right now is like Dave Butler or someone like that, someone who's like a hardcore. One thing that I'm noticing though that's a little bit frustrating is that when I'm turning this thing on and off, I'm not reliably getting this guy to turn on. So that feels like things aren't being cleared out. There might be some capacitor that's not being like blanked out. Because this guy starts drawing. Poor David, it says it's blowing his eyesight. Yeah, I apologize for that. I'm really doing my best, my friend. I can bring the mic, I can bring it down and then wait for a second for it to like whatever, wait for a second for it to zoom in. Another option would be for me to try to use my iPhone, but I think that would be funny. So here's the question though. Do we move on? Do we move on? Oh, Sevens has a great observation. Great observation. Does the keyboard require more than 5 volts? I didn't think about that. Power rating, 5 volts, 50 milliamps. So that's an awesome question. It does, in fact, not require too much. Lanish, I love it. I thought you worked for a software company. Why can't you build analog circuits from 50 years ago? Very wise. You nailed it. You caught me. I'm a phony. I can't hang. That's the whole point, is why we're making this together. We're making this together, right? The whole point is that I don't know what I'm doing. If I knew what I'm doing, you would be watching Ben Eater or some other more useful stream, but not my garbage stream. So here's a question. I think I'm just going to move on. Is there any way to check to see if power is getting back to the keyboard controller module? Well, that's a great question. So let's do that real quick. So there's a couple things we can do. So we can just pick, we have to check over, like over what is the voltage between two things. So we're going to, plug into something here and I can see that there's 5 volts. Oops, you can't see that. Sorry. How do we get this guy over here? Sorry. So you can see that there's obviously 5 volts right there. And we can see You got 5 volts on data and on clock. So there's voltage. I think we can assume that so Sevens is making a great point. I think the keyboard is fine. I think the circuit is fine. My current working guess is that there's something that they're missing in the instructions where I have failed to either flash something, because I notice when I get to this part, it pops up and it says milestone tests. You have assembled the video and the keyboard system. Test all blue. After the test, remove the blue wires. That's cool, because the blue wires were for the test. Now it says you can test them with LEDs. The problem is I don't have LEDs. Like, I don't have freaking 8 of these guys, you know? This is like a potato quality. Let's try that again. So you see they're typing numbers and you can see. Yeah, and Jason Bourne points out that there's a typo there that says Labord, which I thought meant something, but it's just a typo. Here, what they've done is they've set up 8. Oh, this is actually kind of interesting, though. Let's look at this here. They've set up 8 of these. Oh, I know what they're doing, actually. This is interesting. Notice that in this example, they don't even have the video controller here. They're just testing the keyboard in, like, alone in the world. And they're testing it. Where have they been plugging in the LEDs, like, directly? I mean, I guess you could do that. I don't know if that seems like a good idea. David says plug in one LED and mash the keys. I think you're right, actually. So here's an LED. Do we think we just pull these guys out? Because I think we're going to just give up on those 10 and move on. Check the polarity of the LED. So polarity is going to be positive here. Now we might burn our LED out. I'm mashing keys. So I think I'm gonna pull these out. Pull out the bus there. And whoop, cheat a little bit. And see if we get anything. That kind of gets me back to here, though, doesn't it? See, there's voltage there. And there's your data. That's your clock, rather. So this seems hot. Like, that's, I mean, I guess it's flashing 1,000 times a second, but that's going. It seems to stay on regardless. Oh, interesting. So 7 says maybe this means the LED lights on the keyboard. I don't think so, because again, in this video, they're making 8 LEDs light up as they hit buttons, and you're basically watching the bus light up. And then down here, they're typing at the top there. Now this is interesting, though. You can see at the top of the terminal in this blurry YouTube video that they're typing there. Yeah, but look at that. Michael says in the video the clock data wires aren't connected. So what's interesting about that to me is, how are they starting the terminal? What is going on? They've got the 3 green ones that I've got here, or 4 green ones, and this black one, and the power. So they're definitely powering this guy up. And then in the other video, they turn it on, and they've actually unhooked everything, see? And what they did is they put 8 LEDs right there. Right? So they've got 8 LEDs like lined up here on this guy, and they're probably not even doing resistors, they're just breaking rules here. Oh, that's interesting. So I've got data. These are all hot. Yeah, I don't know, man. And then it is concerning because here you've got data. Are they reversed? Are those reversed? No, that's going over it. That is going over it. See how hard it is to see right there? This is where I would want to go and get some more detail. So this D2, or should those be reversed? And if I reverse them, will I cause a problem? In the video, there's a link for updated code. Oh, okay, hang on, Jafir. Thank you for that. What do we got going on here? We test it with the smart keyword controller and updated driver. Well, that's stupid. Okay. That's great. Oh, interesting. The problem is, Jaffer, we don't have a way to go and port that. Right? Like, the problem here is that I need a way to flash this keyboard. I don't know what's happening on this keyboard controller right now. And because of that, I'm kind of in the dark, literally, because I don't know how to get that guy, if that's legit or what's happening right there. And that's a problem. Does that make sense? So the question then is, in the instructions, clock, see, look, if I just go like this, that looks more the way that the video does. But we don't. Inga is asking a great question. Is it purposely testing you to think through problems? That is a good question. I don't think so. I think this is a poor instructions. It makes more sense that it be poor instructions. My spidey sense is telling me, because think about it. You know, if you're a small business, you make a system like this, it makes more sense that you simply made a mistake in the documentation than you are consciously trying to hurt your user, which is me. Because I've gotten this far, they obviously think that it should work. The problem is it has this screen code assembled on this video monitor here, it's unclear what it is that's going to cause this thing to switch back into terminal mode. So it seems to me like, oh, she scared the crap out of me. John on TikTok just said maybe the chip is on backwards. That's a great freaking question, actually. I think that would be odd if it was on backwards. I would be pretty disappointed in myself. Let's get rid of this ad. Thank you, ad lady. And let's go back here. It doesn't help that their videos are potato quality, but you can see the notch right there. And that is also right here. So I am going to go and say it is not. Inga, who is an electrical engineer and knows more about this than I do, is saying where is the dot on the chip? Yeah. The dot is on the lower left in both instances. Oops. Sorry. I'm still learning how to use this. So let's think about this. Pretty sure it's right in both instances. It's seated correctly. I can unseat it and check again. But I'm 90% sure that this is well seated. It's possible I messed it up, right? I could have messed it up by, I don't know, static electricity or something. That little foot there doesn't look super happy, but it seems chill. I'm going to double check that foot. Bend it in a little bit. Maybe I missed one pin. Wouldn't that be funny, my friends? The wiggle test, Hal says on... Oh, Inga, so what's going on is we went through another 30 or 40 steps. No magic smoke, Web Developer Ninja. Thank goodness. No magic smoke. What we did, Inga, is we installed the keyboard controller. And it is unclear from the instructions because once you reach this step in the instructions here and you hit next, it kind of sends you this like, congratulations. So you get here and it's like, you did it. And you're like, oh my God. So then I went and grabbed a PS2 adapter here and turned it on. And we expected we'd just start slapping the keyboard. But I don't know how to tell this thing that we're in terminal mode. Now, of course, nothing's going to happen now because we just unplugged all of these wires. Oh, Bob just warned me. Thank you for that tip. I just used a screwdriver to reconnect these, and I probably shouldn't have done that. Thank you, Bob, for that reminder. I definitely don't want to short the chip, so thank you for that. A little late, my fault, but a valid point. So I'll just redo this real quick. 3 to 3. Three to 3. And 5 to 3. No, that's wrong. 3 to 5. I shouldn't do it when it's on. I'm getting frustrated now. 5 to 3. And then 6 to 6 all the way to the end. So 13 to 13. 12 to 12. 11 to 11. D10 to D10. 9 to 9. Almost done. If it works now, I'm going to be like, what? 8 to 8. Seven to 7, and then this guy, if I remember correctly, was too short. Didn't he end up being too short? We'll make another one real quick. Does your capacitor touch your clock housing? Great question, Kirill. Let me check. Oh, it does. Oh my goodness, hang on. I think Kirill may have cracked something. Let me fix this real quick. 6 to 6. So he's pointing out we've got this clock housing here and the capacitor is touching it. Okay, I've just bent that out of the way. What Kirill is observing very wisely is the housing of this guy here was touching that. Now Harley is making an observation that maybe this is wrong. We have data going to D4. What? Did I screw it up? Oh, I think this is where I'm starting to think I'm getting tired. And I need to stop. No, that was right. Data to 2. It's confusing because of the way that the wires look in reality. Now, and Michael says the clock wires are adjacent instead of having a 1 pip gap. Let's check it out. Let's go look at the video. Oh my goodness. What in the heck is that? You guys. Okay, hang on a darn second here. 1, 2, 3. They're into 3 and 4. Not 2 and 4. No, look. 1, 2, 3. That's 4, right? Let's look at this again. Sorry about the zooming, everybody. I'm learning. Yeah, Kirill, the video with the full board is bananas, so we're not gonna. That's not gonna help us because these blue ones actually don't belong here. So that's pretty clearly together there, isn't it? It's going 1, 2, 3, and then 4, 5. So 1, 2, 3. They've got it in 3 and 4, and I've got it in 2 and 4. Yeah, D4 and D5. No, it starts with 0. That's interesting. Okay. And then this other video that they do, they don't use it at all, which is disturbing. D4 for data. Yeah, and then the clock, they've got it elsewhere. Okay, so I turned it back on here. I think you're onto something though. These videos are not matching up with reality. Yeah, okay. So kids, look. Look at my keyboard. See how it's flashing? That's the clock is connected to the keyboard right now. I'm going to move it over one. It is very weird instructions. I agree. Sevens asked if the instructions are versioned in the URL. They are not. So I've just moved stuff over. I'm not getting my screen to turn on anymore. That turns on. If I move it over one, okay, there we go. It still turns on. We've moved it over to D3. Screen's coming down. I'm typing on the keyboard. Keyboard's not doing anything. Turns on for the moment, just for a second. Yeah, so this is a great point. So Hide Flow Life is saying, let's look at the schematics. Okay, this is a great observation that you're making here. So this is where things get a bit dodgy. So we are using the problem is it's an Atmel. The problem is that in order to make this, it's a keyboard controller that's basically like a little Arduino of its own, and they've presumably coded the thing. And I can look at the pinouts of this, but then I would need to figure out. It could be just that it's badly flashed. Now you made the observation to hit caps lock. Caps lock is not doing anything, neither is numlock, because those are actually handled not in the keyboard itself, they're handled down in here. So unless there's a numlock or unless someone wrote code to turn numlock on, numlock's not going to turn itself on. But this instructions are pretty unambiguous, and if you look down here, it actually calls it out. B44 and B46, they're actually calling it out by row number here, 46. Inga's asking if you can get the instructions. Yeah, you can all follow along. If you want to go to instructions.smartykit.io, I don't think you need to go in there, and you can even click on parts list. So if you click on the parts list to the point that was being made earlier, you can see all the different components, where they come, and how it works. So yeah, you don't need to do anything. So let's go and look at their Discord. Oh, that'd be fun. Look at that. A little breadboard of its own to make it easier to figure these things out. That's pretty cool. Ah, Jaffer makes a really great point. I think this is worth calling out. So if we go back here and we point out that the video controller is a simulation and they were shipped like this. You've got your board here and then your chips here. And those are all Atmels. These are basically little Arduino programs that are running this stuff. Jaffer is making an observation that maybe that the keyboard one is not a keyboard one at all, and maybe it's something else. It could be mixed up in the factory. So that's super interesting. Yeah, great question. Let's see if anyone's around in the Discord. Oh, here we go. Everything is wired up and we've checked voltage on everything, comma, but it doesn't appear that the data line is getting what it expected from the PS2 connector. Clock is D4 and D2. D4 and D2 respectively. Yeah, Bob is making a funny observation here because what we're doing is we're really simulating an Apple computer. For those of you who are just joining us, what we're doing is we're building an Apple computer from SmartyKit from scratch. It's an Apple One, just like Wozniak built, but they're simulating it, right? It's a cost-cutting thing. So what they're doing is they're using what are called Atmels, which are these little microcontrollers. And these little microcontrollers are cheaper than using, of course, the original parts and simpler that Woz used. We could have built all of this, what are called 7400 series parts, but that would have been a hassle. And what we have here is a keyboard controller and a video controller. And we've plugged our keyboard in right here. Here's my keyboard. And what's interesting about all of this right now is when we turn it on, you see our clock flashing right here. And what we're not seeing is anything. Did you try with a different keyboard? Isn't that always the way? I don't think I have a lot of PS2 keyboards lying around. But wouldn't that be funny if it was just a keyboard issue? Yeah, so Rob Barber makes an interesting point about not having a chip programmer. So I do have a kind of chip programmer, but I don't know if it's going to solve our problem, because that gets us into a whole other world. I have one of these. You can tell me if this is what I need. Right? So this is a little IC chip programmer, and then I would go off for an hour and a half and dump what's on that chip and figure that information out. The other option is to figure out how to flash that. But that just seems like it's beyond the scope of what is expected for a kit like this. So this gentleman said I had trouble with one that didn't do USB to PS2. Sevens makes a very good point. It could be DNS. It probably is DNS, my friends. Very likely. Let me think about this. Do I have a adapter? Let me see. Most adapters go the other direction. This is a very old thing right here. This is a PS2 connector. He's using a PS2 to USB connector. So he's basically saying if I had a different keyboard, that it might potentially work. Do I even have that? Yeah. So all these are correct. I'm just double checking all of my wires. We've got our, I know we've done this. We always want to assert your assumptions. You just never know. Clock to D4, data to D2. Nothing's bumping anything else. Our resistors and our capacitors are all correct. I'm going to zoom in. My eyes aren't working right now. This might be an idea for you all to be able to see better. Yep, that all looks exactly as it's supposed to. So this gentleman said he did it a while back. Sevens is saying, can I check for high and low on the bus lines? Yeah, we can do that. We can do that. What's the button on the left? This button on the left is supposed to reset the video. See? I just pushed the button and this guy reset. Yeah, and see, Bob is making a great point, is that right now is what I need, is I need my oscilloscope back. I need my logic analyzer. So I actually had one that was called a Pocket, and I loaned it to my nephew. And it's a lovely little device, looks like this. Come on, computer, people are watching. So basically, I'd be able to go and watch the data line like this. I'm going to have to ask him for it back. Yeah, Sevens is also pointing out I need a third hand here because right now I'm managing two different chats from two different streams. So this, actually, that's a great point. He said 0 could be low. So I would expect then, let's see if I can get one of these to stay here. I need one of my kids to get in here. What I would want to do is, hang on a second, how am I going to do this? So I want to poke that in there, you know. What I want to do is push a bunch of buttons, and I want to see that light up. But the other issue, of course, is that I should be able to take the LED and, you know, I could potentially pop the LED if I'm not careful here. And I would push buttons on the keyboard, and I'd expect this guy to light up. But I'm not even seeing that. Now, if I flip it, of course, it will light up because I'm giving it voltage. But if I do it like this, this guy here should light up as being one of the bits. Now, I only have the one LED. I guess I can probably go find some other ones. So Bob is suggesting I buy a cheap logic analyzer. That might be a good idea. So let's see if anyone's joined who's going to help us. Hey friends, we are building an Apple I computer from scratch. Dee is saying, can I meet you on Redmond campus this summer? I don't live in Redmond, actually. I live in Portland, Oregon. So I'm afraid I am not in Seattle, my friends. So this light here that I just set up, I would expect that to light up. And if we go back and compare it to this guy, remember what we were doing before. I think it was that one. When we did this, you see how he's pushing the button there and it turns on. And as he pushes buttons on the keyboard, we see the bits. That's what I want to see. And I'm not seeing anything. But the part that's weird, that I find so concerning, is that these two wires are connected different. And that doesn't make any sense. So nothing in the Discord. I think I'm going to give up and go make dinner because I'm getting frustrated with myself now. And I'll probably go live a little later and figure this out. But because I'm not getting reliable instructions, I feel like I've been let down a little bit. Jaffer says, what's the Atmel part on the controller? This is an Atmel Mega 328P, 328P, Atmega 328P, pretty much standard. Yeah, and Sevens is pointing out that there's just microcontrollers. Just regular microcontroller, nothing special here. It's pretty clear that they're simulating a keyboard controller with their code. But that light's not turning on. So that makes me wonder if this guy's not booting up correctly. Oh, Kirill makes the point that the LED is not lighting in the video. That's probably not lighting in the video because they don't have a clock plugged into it. Oh, that's an interesting point. Hang on, Kirill. I think you might once again be on to something. So Kirill, yeah, so this is the other point. William Irvine is saying, try it the way they did it in the video. You're basically saying, take everything apart, rip it all apart. Yeah, that's a good point. Rip it all apart and start from that. The light is not in the video because the clock is not plugged in. So where is my guy getting? Seven says, I'm only pressing a few keys. I'm trying to do what they're doing in the video, which is pressing the top keys. I'll press them all, but I'm not seeing anything. It's not making a difference. Yeah, I'm pretty sure it's not that. And then the fact that it's not flashing in the video is interesting. That's pretty clearly the clock. Maybe I plugged that in wrong. Let's back up. Good question. Helpful people. So let's go back here. And we'll back up a little bit. And let's just reset here. So they've got A5 plugged into the leg of this guy. And what did they name that? What did they call that? We back up a couple of steps. Low rate clock LED wire. Yeah, that's pretty clearly called the clock LED. Yeah, so Kyle, who just joined us on TikTok, what we're doing here is we're trying to build this guy. We've got a PS2, we've got our data wire, and we've got our clock. This is our clock, and this pretty clearly should be doing that. I'm feeling pretty good about that. What we're not seeing is we're not seeing anything coming from our keyboard controller over to our video controller. And as we follow the instructions, we got to the end. You see that blue? See this blue right here? We're building up that bus. And then it goes and it pops up a congratulations. And then it says, this is the part that it says weird. Upload keyboard driver with auto start. And see symbols on display. So I'm going to guess that the keyboard driver is not actually a thing. I can get rid of that LED, to be clear. And see if that makes a difference. And that does not. So I'm gonna call it. It's time to take a break, my friends. But we're having fun. I'm learning. I'm learning a lot. I will see you all later. Oh, I'll do one last thing there. Yeah. So someone said try typing before the screen is painted. That would basically tell it that I'm here. That's a good observation. I'll put this wire back in here. So I'm typing, turning it on. Oops. Yeah, see the part that's concerning to me is you can see here the keyboard is not reliable and it's flashing now. That means it's getting voltage. That's the clock. I feel good about that. I think it's a problem with this guy here. So I'm going to spend some time on their Discord and I'm going to learn about that. So good fun. Thank you so much for spending time with me today. Some of you just showed up. I think that's always fun. But either way, thank you all. I see lots of great friends in the chat on both YouTube and on TikTok. Thank you all for your help, and I will let you know how this turns out. Please follow me. All the places that you follow people, and follow me, and I'll let you know what happens